Lesson 1.3, Exponents and Order of Operations. As Module 1 in Algebra 1b is a review of some modules from Algebra 1a, I have made a combination video of the other videos I had already made for Algebra 1a, and those will cover all of the information for Algebra 1b, Module 1.3. It may seem a little disjointed, and it will have some other lesson numbers in there. Just ignore those and know that this is for Lesson 1.3 for Algebra 1b. Lesson 1.4, Order of Operations. What's an operation? An operation is a mathematical process. So, for example, adding, subtracting, multiplying, dividing. And why do we need a specific order of operations? Well, we need a specific order of operations because math is universal. The order of operation ensures that everyone in the world will perform the same math problem in the same way and come up with the same answer. So, for example, I have two problems. One I will do correctly, and one I will use no order of operations. So in the first problem, if I'm using the order of operations, I multiply first, then add, and I come up with the answer 18. If I don't use the order of operations, I do 8 times 10, and I come up with the answer 80. Obviously, two very different solutions. How would we know which one's right? Using the order of operations, there's a couple different ways to remember the order. You may have heard PEMDAS before. PEMDAS is a mnemonic device that helps you remember the order of operations, which is parentheses, exponents, multiplication, division, addition, and subtraction. These go in order. First, we do parentheses. Well, parentheses is not just parentheses, it's all grouping symbols. This includes parentheses, braces, brackets, absolute value, and fraction bars. We perform all operations inside of grouping symbols first. Next, second is exponents. We calculate all of the exponents. Third is multiplication or division. A common misconception is that you have to go through and do all of the multiplication first and then go through and do all of the division. You do multiplication or division in order as you move from right to left across the problem. Finally, we add or subtract, again, in order as we move right to left across the problem. Other ways to remember the order: please excuse my dear Aunt Sally, and one that one of my former students came up with: purple elephants munch daisies all Sunday. I also like to think the order of operations as a royal family. So I call it the royal family of mathematical operations. At the highest level, we have the king. These are our parentheses. The king is what comes first in the royal household. You defer to the king. Next, we have the queen. The queen is our exponents. Then we have the prince and the princess. Now, the prince and the princess have equal weight in the royal hierarchy. That's multiplication or division. And finally, you have the peasants. The peasants are at the very bottom rung of the ladder, and that's addition or subtraction. So let's try some example problems. In our first problem, we have 72 divided by 9 plus 7. Now, this one is set up that if you just went straight across, you'd actually end up lucky. But we need to divide before we add. 72 divided by 9 is 8. 8 plus 7 is 15. 2 plus 7 times 5. Multiplication comes before addition. 2 plus 35 is 37. 9 plus 8 minus 7. Addition and subtraction have the same weight, so we go in order. We do 9 plus 8. Then we subtract 7 and end up with 10. 6 minus 32 divided, or sorry, 9 minus 32 divided by 4. I need to divide this 32 by 4 first. So I have 9 minus 8, which will give me a 1. 5 times 10 minus 1. We need to perform our operation inside the parentheses first. So although this is multiplication and this is subtraction, subtraction is inside parentheses and parentheses is king. So this is going to be 5 times 9, which will give us 45. I have 48 divided by 4 plus 4. Again, addition inside parentheses has a greater weight than division because of the parentheses. So I have 48 divided by 8, which will give me 6. And here I have 20 divided by 4 minus 10 minus 8. I have parentheses inside of parentheses. I have to start in the most inside parentheses. So I have 20 divided by 4 minus 2. So 20 divided by 2, which will give me 10. And here I have 4 divided by 4 minus 5 minus 3. Parentheses comes first, then division to give me 10 minus 2, which will give me 8. Here's a couple of other problems where we've added the fraction bar. Fraction bars are a grouping symbol. That means that I need to perform the operations on either side of the fraction bar first. So this is going to give me 27. 2 plus 3 is 5, plus 4 is 9. So 27 divided by 9 plus 3. A fraction is just division, so 27 divided by 9. So that's 3 plus 3 to give me 6. Here I have 8 times 15 divided by 5 minus 5 plus 9. Parentheses come first, so that's going to give me 14, and then division and multiplication come next. Now in this particular problem, you're going, oh, division and multiplication have the same weight, so I have to multiply then divide, but this is a grouping symbol. The grouping symbol means that I need to do that before I multiply. So this is going to give me 8 times 3 minus 14. I'll do the 8 times 3 next. So that is going to give me 24 minus 14, which will result in a 10. Inside these parentheses, 10 plus 2 minus 2. Doesn't matter which order really I do these first in, but I'm going to go in order right to left. Sorry, left to right. So I have 10 plus 2, which is 12, minus 2, which is 10, times 6 minus 1. Multiplication comes next, so I have 60 minus 1, which will give me 59. And finally, we have some more complicated problems with parentheses inside of brackets. We need to do what's inside the innermost parentheses first. 3 minus 7 is negative 4. 4 minus 6 is negative 2. Everything else I write down exactly as it was. Now I have exponents and multiplication. Exponents come next. And I want to take some time really quickly to discuss the difference between this and this. If I have a negative 2 squared and there are no parentheses, this negative is hanging out by itself. So that's negative 2 times 2, which gives me negative 4. If the negative is inside the parentheses, I have negative 2 times negative 2, which gives me positive 4. So be very careful of that. If there are parentheses with an exponent outside of it, you square the negative as well. Think of an exponent like a taser. If this negative and this 2 are hanging out, standing next to each other, and this exponent comes and tases this 2, the negative is not going to get shocked. However, these parentheses show that they're holding hands. So when the 2 tases, it tases them both. Okay, so I know that this is going to give me a positive 4. Negative 4 and negative 4 is positive 16. Now I need to do the addition inside the brackets. 16 plus 4 is 20, and 7 times 20 is 140. Coming down to the next problem, I have 3 minus 6, which is negative 3. 9 minus 6 is positive 3. Exponents come before multiplication, so I have 4, bracket 5, negative 3 squared, that's in the parentheses, so that's a positive 9 minus 3. Multiplication comes before subtraction, so 45 minus 3. Then subtraction inside the brackets before this multiplication, so 42 times 4, and that's going to give me 168. Suppose I should practice good skills and circle my answer. Okay, 7 minus 9 is negative 2. 3 minus 5 is negative 2. This one's squared, this one times negative 2. Brackets and a 5. Exponents come before multiplication, so negative 2 squared is positive 4. Negative 2 times negative 2 is positive 4. It's going to give me 5 times 8, which is going to give me 40. And this one I'll just work out to the side. I'm going to do this one first, and then this one. So I'll have 6 bracket 5 parenthesis negative 4 squared plus negative 2 bracket minus 3. This is next, which gives me positive 16. Come up this way so I have room, sorry. 6 times 5 times 16 minus 2 minus 3. 5 times 16 is 80 minus 2. 80 minus 2 is 78. 6 times 78 is 468. Minus 3 is 465. Lesson 1.8, Exponents. You'll remember exponents from lesson 1.4. She was our queen in the order of operations, meaning that exponents come second after grouping symbols. In math, there are a lot of shortcut notations that indicate various operations or symbols for different functions, things of that nature. Multiplication is actually a shortcut that was developed to deal with repeated addition. 3 times 5 is either 3 being added together 5 times or 5 being added together 3 times. And that's fine if it's short like this, but what if you wanted to multiply 140, or rather add 140 together 231 times? You didn't want to write that out, so multiplication was developed to deal with things like that. Exponents were developed for a similar reason, except instead of representing repeated addition, exponents were developed to represent repeated multiplication. So instead of having to write 5 times 5 times 5 times 5 times 5 times 5, we can just write 5 to the 6. That's a lot shorter. So let's break this down a little bit. If you see this kind of notation, the number on the right that's smaller is the exponent, and the number on the left that's larger is the base. The exponent tells us how many times we have to multiply the base. So 4 squared is 4 times 4, that's twice, which equals 16. We were already familiar with squares, but an exponent can be any number, so can the base. 3 times 5 is going to be to multiply 3 by itself 5 times, which will give us 243. 6 to the third is to multiply 6 by itself 3 times, which will give us 216. 2 to the 10th is to multiply 2 by itself 10 times, which would give us 1024. The thing to remember is that you multiply the base, the number on the bottom, by itself as many times as the exponent says. 2 to the 10th is 10 twos, not 2 times 10. If you're using a calculator, there are a few buttons for exponents. Some calculators have an X with a small y, others have a Y with a small x, and some use what's called a caret. In either case, you'll enter the base, then you'll press that button, then you'll enter the exponent, and then you'll press enter, and that will give you your answer. Exponents with fractions. Now, if I have 1/4 to the power of 3, that's the same thing as multiplying 1/4 times 1/4 times 1/4, which will give me 1/64. Another way to look at that, 1/4 to the third is the same thing as if I distribute this exponent to the 1 and to the 4. So I'll get 1 to the third over 4 to the third, which will give me 1/64. 2 to the 5th, 2 over 5 to the 5th, that's 2/5 times itself 5 times, which should give me 32 over 3125. Or again, I can distribute this exponent to both the 2 and the 5, which will give me 2 to the 5th over 5 to the 5th, which is 32 over 3125. Last example, improper fractions are the same. 7/2 squared is 7/2 times 7/2, which is 49/4. Or I can distribute that exponent to the 7 and to the 2 and have 7 squared over 2 squared, which is 49/4. Now, negative exponents. Negative exponents are illegal in math, unless you're scientific notation. That's the only time negative exponents are allowed. When a negative exponent appears, what we do is we take the reciprocal of the number. So to simplify a negative exponent, I have 4 to the negative 2, and as I mentioned before, exponents are illegal, and so since they're illegal, we throw them in the basement and make them positive. So 4 to the negative 2 is the same thing as 1/4 squared, which gives me 1/16. If the exponent is already in the basement, and it's negative, 1/3 to the negative 4, we bring it up top. 1/3 to the negative 4 is 3 to the positive 4, which is 81. And if we have 2 negative exponents, 5 to the negative 3 over 6 to the negative 2, they switch places. This becomes 6 squared over 5 to the third, which gives me 36 over 125. And this is true with any negative exponent. You switch sides of the fractions. So if it's on top, you put it in the bottom. If it's in the bottom, you put it on top. We can also have exponents themselves that are fractions. If a fraction is an exponent, it indicates a root. So 16 to the 1/2 is a square root. Like this. And the square root of 16 is 4. 16 to the 1/3 is known as a cube root, which looks like this. See the little 3 right here? The cube root of 27. Cube roots occur when you have an exponent of 3. 3 to the third is 3 times 3 times 3, which is 27. So the cube root of 27 is 3. Right now we're only going to have squares and cube roots, but exponents could be any fraction, and those will be dealt with in future math courses. Lesson 1.12, Scientific Notation. Scientific notation is a way to write very long numbers in a shorter way. Again, mathematicians like shortcuts. This is a way to not have to write such long numbers. It's also an estimation technique, so it helps to do calculations with very large numbers or very, very microscopically small numbers in an easier way. The standard form of a number is the long version. So for example, we have this big long number. It's a lot to write. Scientific notation is the short version. We can write it like this. Now, when you have scientific notation, we have 9.8 times 10 to the 18th. Anytime you have this, these are powers of 10. The number 18 indicates the number of zeros. If we were to just take 10 to the 18th, we would have a 1 followed by 18 zeros. Or it also indicates the number of decimal places. So 9.8, when you multiply it out, from the point to the end of the number would have 18 decimal places, and we can verify that. 3, 6, 9, 12, 15, 18. We can express long numbers in scientific notation. Now there's two types. I mentioned in a previous lesson that negative exponents are allowed. And in scientific notation, a negative exponent indicates a long decimal. So in order to express this number into scientific notation, what we'll do, we're going to count. Now our decimal point in the scientific notation always goes between or after the first non-zero digit. This is where we need to move the decimal place to. Right now it's here at the end. We need to move 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. This is our exponent. So 3,400,000,000 is going to be 3.4 times 10 to the 9th. If we go with a long decimal, again, we're moving to this place after the first non-zero digit, and I'm going to move 1, 2, 3, 4, 5, 6, 7 places. And since it was a decimal, I'm going to have a negative exponent. So I'm going to have 3.12 times 10 to the negative 7. Okay, our decimal's at the end. We're moving to after the first non-zero digit, 1, 2, 3, 4, 5, 6 places. Now this would be 2.091 technically times 10 to the 6th, but in scientific notation, we don't want that many decimal places. You want 2 only. So we're going to round this. So actually we're going to have 2.09 times 10 to the 6th. Why don't you pause your video and try these 3 on your own, remembering that the decimals will have a negative exponent. When you're finished, unpause the video and compare your answers. How'd you do? Sometimes the scientific notation isn't really all that much shorter, but it's still a good idea to know how to convert to scientific notation. If we can go from standard form to scientific notation, we can also go from scientific notation to standard form. What I do first is identify the exponent. Is it positive or negative? If it's positive, I'm going to move to the right. If it's negative, I'm going to move to the left. Okay. Next thing I do is if I'm moving to the right, I will write on the left-hand side. If I'm moving to the left, I'll write on the right-hand side. So here I'm going to be moving to the right. I have a 10 to the positive 5. I write down my first digit. Where the decimal point is, I start counting. I say 1, 2, 3, 4, 5. And then put in any relative commas. Here I've got a negative exponent, so I'm going to start on the right and move to the left. I have 0, 2, 3 after the decimal point, so I'm going to start counting with this first digit. I have 1, 2, 3, 4, 5, 6, 7. Again, I have another exponent that's negative, so I write the after the decimal point numbers, and then I start counting 1, 2, 3, 4. Here I have a positive exponent, so I write down the first digit, and then I start counting 1, 2, 3, 4, 5, 6, 7, 8. Here a negative exponent, 1, 2, 3, 4. And here again a positive exponent, 1, 2, 3, 4, 5. If we multiply numbers with scientific notation, this is one of the areas where the application of scientific notation becomes really positive, especially for scientists and engineers, anybody that has to deal with really large numbers. First, we multiply the decimal portion of the numbers, and then we add the exponents on the tens. So let's just look at this for a second. If we were to multiply this out the long way, I would be multiplying this number. And that's not necessarily so bad, but remember, scientific notation is estimation, so this could have had any number of different digits in it, and it could have been a really long problem to multiply. The way we do scientific notation multiplication, I do 6.1 times 2. That's 12.2. And then I add the exponents on the tens. So we end up with 12.2 times 10 to the 10th. Now, keep in mind, I had mentioned that we want 2 decimal places, so we need to adjust this. We're going to have to move this decimal place. This decimal place is going to need to move 1 place over, so I'm going to add 1 to the exponent because we've, when we were moving before, we were counting how many we moved, so I'm going to add 1. So in actuality, we're going to have 1.22 times 10 to the 11th. Now if I multiply here, I have 4.4 times 1.6, which gives me 7.04. And that's nice because I don't actually have to adjust it. It's got the right number of decimal places. And then I do 6 plus negative 9 to give myself a negative 3 for my exponent, 10 to the negative 3. There's 2 more examples. 2.2 times 8 gives me 17.6. 6 plus negative 12 is going to give me a negative 6 for an exponent. But again, I'm going to have to move this. I need to move one place this direction, so I'm going to add one exponent, which will give me 1.76 times 10 to the negative 5. For this next example, 3.4 times 5.4 is equal to 18.36. Negative 5 plus negative 4 will give me a negative 9 as an exponent. I have to move one place over and add 1 to my exponent, which means I'm going to have 1.836 times 10 to the negative 8, but again, I can't have 3 decimal places here, so this 6 needs to round that 3. Give me 1.84 times 10 to the negative 8. In scientific notation, in your final answer, you only want 2 decimal places. And you want a number before a decimal and then a maximum of 2 decimal places. Why don't you try these 4 on your own? Make any adjustments that are necessary. Pause the video while you work on those. Come back and check your answer. How did you do? Did you make the correct adjustments? Okay, let's look at dividing numbers in scientific notation. Now, when we divide numbers in scientific notation, we follow the same process. We divide the decimal part. And instead of adding the exponents, we subtract the exponents on the 10. So if I do 9.2 divided by 2, I get 4.6. And if I do negative 8 minus negative 6, trick for minusing a negative I do is a smiley face, because that's positive. So it's negative 8 plus 6. So it's going to be 10 to the negative 2. 1.161. Now again, in the final answer, only 2 decimal places, but in the problems that you're given, that's not always going to be accurate. Divide that by 4.3, and you're going to get 0.2697. I'm just going to go ahead and do that. Times 10 to the negative 9 minus negative 6. That's happy. So 10 to the negative 3rd. I need to adjust this. This time, I'm not moving to the left as I've done before. I'm moving to the right. Now, when I moved to the left, I added an exponent. When I move to the right, I'm going to subtract an exponent. So instead of being 0.2697, when I round this, I'm going to get 2. The 7 will round the 9 up to the 10, and that will round up to the 6 up to a 7. So I'm going to get 2.7 times 10 to the negative 4. Okay, 4.625 divided by 1.25 is going to give me 3.7, and 10 minus 4 will give me 6. I have 3 more example problems. Why don't you pause the video and try these and see how you do? Well, how did you do? Were you able to make this adjustment? Remember, we're moving 1 decimal place this direction, so we subtract 1 exponent. The other 2 problems, we didn't have to make those adjustments.